Hello everyone, in this PowerPoint presentation video, we will look the redox reaction in the electrochemical cell. This is basically an introductory slide which also gives a beautiful diagram of the Daniell cell, which is the application of the redox reaction. Let's move to the next slide and see how it is proceeding. First slide is about the redox reaction. The definition of the redox reaction states that redox reaction are those in which the electrons are transferred from one species to another. Electron transfer involves production of electricity. Let's move further to see what is next. There are the examples of redox reaction. In this presentation, we had involved 4 examples of redox reaction in which the reaction can be seen. Let's move further to the application of redox reaction, which is a Daniell cell that I had told you earlier in the introductory slide. So now let's discuss about the definition of the Daniell cell. A Daniell cell is typical a galvanic cell. It is designed to make use of the spontaneous redox reaction between zinc and cupric ion to produce an electric current, which is important. So now let's move to the next slide, which is about a GIF form of Daniell cells working, in which we can see how the electrons are going from anode to cathode and how the current flows from cathode to anode in the galvanic cell. Let's move further to see what happened next. This slide shows us the working of the Daniell cell. Daniell cell's working consists of the copper vessel in which saturated CuSO4 solution is filled, which acts as a depolarizer, and a dilute H2SO4 is filled, which acts as an electrolyte. And zinc amalgamated rod is immersed in Zn2SO4. In copper vessel, there is a transparent layer all around just below the upper surface in which the CuSO4 crystals are kept in contact with CuSO4 solution. Due to this, the solution always remains saturated. So basically, this is the working of the Daniell cell. Now let's move further to see what happens next. Now, steps involved in the Daniell cell. These are the steps that are involved in the Daniell cell. That are, the Daniell cell can be conventionally represented as in the following reaction, which is zinc plus 2 positive copper ion, which is in the aqueous form, which gives us Zn2 positive ion plus copper. In a Daniell cell, electrons flow from zinc electrode to copper electrode through an external circuit, while metal ions from one half cell to the other through the salt bridge. Here the current flows from current electrode to the zinc electrode, that is cathode to anode, via an external circuit. Daniell cell is a reversible cell, while a voltaic cell may be reversible or irreversible. Let's move further and check what happened next. The cells reaction. Yes, the most important part of the Daniell cell are the cells reaction. Let's see and have a look over them. Ions. The zinc half cycle oxidation reaction occurs. In the zinc there is oxidation, and in the copper the radiation reaction occurs. Let's move further to see what happens. Conditions for voltaic cell. The EMF of external source is more than that of the voltaic cell, so that current may flow from external source into the voltaic cell, and the cell's reaction can be reversed. If EMF of the voltaic cell is more than that of external source, current flows from the voltaic cell into external source. Let's move further and see what happened next. Salt bridge. Salt bridge is a device which maintains electrical neutrality in two compartments by allowing movement of ions towards anodic compartment and cations towards cathodic compartment. Let's see what are the features of salt bridge. Features of salt bridge involves, it is a glass tube having potassium chloride or zinc nitrate in a gelatin form. The gelatin allows ionic movement but prevents any kind of mixing. In case of potassium chloride or ammonium nitrate, the ionic mobility of cations and anions are the same. Let's move further and see what are the functions of salt bridge. Functions of salt bridge are, a salt bridge acts as an electrical contact between the two half cells. It prevents mechanical flow of solution, but it provides a free path for the migration of ions to maintain an electric current through the electrolyte solution. It prevents the accumulation of charges. A salt bridge helps in maintaining the charge balance in the two half cells. A salt bridge minimizes or eliminates the liquid junction potential. Let's move further. So now we are at the end of our presentation. This presentation is prepared by the third group of class plus 2B chemistry, which comprises the members Jaskirat Kaur, Khushdeep Kaur, Manan Kumar, Mandeep Kaur, Manpreet Singh and Shivang Tiwari. Roll numbers are 12, 13, 14, 15, 16 and 27 respectively. Thank you for giving your wonderful time to our presentation.